Alright, today is Monday, 12/1, and we're going to be talking about word and formula equations. So this is converting from words to formulas and also from formulas to words. We'll do both examples. So, first and foremost, naming rules and polyatomic ions are still important. They're very important. They're very, very important. Don't forget the naming rules and polyatomic ions. If you've forgotten them, go back over them. This entire unit is going to be based on naming rules and polyatomic ions. They're very, very, very important. All right. So the first step in going from word to formula or from formula to word is to identify the facts that are being represented. And I'll pause here and give everyone a moment to catch up. So, by identifying the facts being represented, what I mean is you need to identify what the reactants are, and the reactants are always on the left side, and what the products are, and the products are always on the right side. And on the right or left side, by that I mean the right or left side of this yield sign. So, if it is on this side, it is a reactant. If it is on this side, it is a product. So it all depends on which side of that yield sign. Again, reactants on the left, products on the right. Also very important. Forevermore, reactants will be on the left and products will be on the right. You can pause this video if I'm going too fast or people need a little time to catch up. The second step for going from word to formula or from formula to word is to state or write how those facts are being represented. You need to state how they're interacting. So we're going to do that on the next slide for two different equations. One going from word to formula, one going from formula to word. You can pause here if people need a little more time. Alright, so our first example, we have FeNO3 plus SnCl4 yields, this is yields, tin nitrate plus iron chloride. Alright, so having to say out every time FeNO3 plus SnCl4 turns into SnNO3 plus FeCl2 doesn't let me know that you're a scientist, doesn't let me know that you have any background in the sciences. So what we're going to do is you're going to use the naming rules and your knowledge of polyatomic ions to properly name these things. So, the first step, we look at Fe. We're going to name them all individually first. Fe, if you look on your personal periodic tables, is iron. And then the question becomes, is iron a transition metal? Iron's number 26. It very much is a transition metal, so we are going to need parentheses. We're not going to talk about how we're going to fill those parentheses yet, just that we will need them. There's the back end of our parentheses. Alright, NO3. NO3 is a polyatomic ion you guys are very familiar with. If you're not, study your polyatomic ions. Tell the person next to you what NO3 is. Alright, heard a lot of people say nitrate. Psych, didn't hear anyone say nitrate because I'm not even there. And nitrate is the correct answer. The way we figure out what charge goes in here is by remembering what charge is on nitrate. So, on our nitrate polyatomic ion there is a -1 charge. But because we have two nitrate ions, 2 times -1 equals -2. In order to cancel out this -2, our iron must be +2. Since we have only one iron, the charge on our iron must be 2. So we have iron 2 nitrate. First one done. Then we have to go ahead and tell me what's going on here. That plus sign we're just going to refer to as combines. So iron 2 nitrate combines with, next up, SN. SN on your personal periodic tables, you should be able to find that it is tin. Tin is a transition metal or a post-transition metal, so we're going to need some parentheses. And then we're going to name the next thing chlorine. Because this is an ionic compound, and we'll be working with ionic compounds most of the time, there's no need to worry about this being like a tetrachloride. That 4 does not matter with ionic compounds. So we're just going to write the fact that that is chlorine, but you change the ending to "ide", so it is chloride. Now we've got to figure out the charge on our tin. If you look, chlorine is a halogen. It's in group 7. The charge on all group 7 elements is -1. So 4 times that -1 equals -4. So if the charge on our chlorine is -4, the charge on our tin must be +4. So this is tin 4 chloride. So far we have iron 2 nitrate combines with tin 4 chloride to yield. This sign right here means to yield or to form. Then we move on to the second part. SN, fortunately that hasn't changed. SN is still tin. And the beauty of these problems is that the charge will never change. So if it was tin 4 here, it is going to be tin 4 here. That charge will never change. Next thing we need to name, NO3, but we've already named NO3 back here. If it was nitrate here, it's still nitrate here. So this is tin 4 nitrate. Next we do this addition sign. Because it's an addition sign, we say that it... that's odd. Should be... Oh no, yields. Sorry, my mistake. We'll back up for a second. So, we've got our tin 4, so it yields tin 4 nitrate, and, so on this side of the reaction arrow it's and, on this side it's combines with, because these two are combining to form these two products. So they have formed tin 4 nitrate and lead, but it's not lead, it's iron. Boy, sometimes writing is hard. So, forms iron, and if it was iron 2 here, it's going to be iron 2 here, iron 2, if it's chloride over here, it's chloride over here, so iron 2, chloride. There, that looks nice. Alright, that is one half of how to do these. The other half is to go from the word form to this formula equation. So, our next example problem will do just that. So this example problem says lead 3 phosphate combines with magnesium chloride to form or yield lead 3 chloride and magnesium phosphate. Take a second and write that down. You can pause it to give everyone a chance to write it down. Alright, so first thing we're going to do is go in order. We've got lead and phosphate. So the first thing I'm going to do is write my lead. And I'm going to write my phosphate. Now, fortunately, I didn't have to do anything here with charges. because as you guys know, the charge on phosphate is -3. It's one of your polyatomic ions. So if the charge on lead is +3, we don't need to add any subscripts here, and we don't need to put phosphate in parentheses and add any subscripts there. It's fine because the -3 is canceled out by the +3 very nicely. Alright, next it combines with magnesium chloride. So, combines with magnesium chloride. Now, in order to balance this, we have to figure out the charge on each of these. So here we knew that lead was +3 because it told us in the problem. We knew that phosphate was -3, so we knew that they canceled each other out nicely. But here, if you look, magnesium is in family number 2. It's an alkaline earth metal. Because it's in family number 2, its charge is +2. And chlorine is a halogen, so its charge is -1. So how many chlorines do we need in order to cancel out the positive charge of magnesium? We need 2. So magnesium chloride is actually MgCl2. Hopefully you guys remember that from your naming rules. Alright, next we go, so we've got magnesium chloride taken care of. So to form or yield is just our yield symbol. And next we have lead 3 chloride. So start off with our lead there. And what does it say the charge is on our lead? Tell the person next to you. Good, so it's a 3+ charge. And chloride is really just chlorine, but you've changed the ending to "ide." The charge on chlorine is still a negative. So in order to cancel out the +3 charge of lead, we need 3 chlorides. Almost finished. And, it's just our little plus symbol there, magnesium phosphate. So, we've got magnesium here, and we've got phosphate here. I'd like everyone to take a minute to at least write the charges that each of those have, and remember the charges haven't changed, and try and balance them, putting subscripts here and here. So take a moment and try and do that on your own. So continue working if you're going. I'm just going to catch up. So as I look at this side of the reaction, or on the periodic table, I notice that magnesium has a 2+ charge. And as I remember back to my polyatomic ions, or look on this side, I notice that phosphate has a 3- charge. So, what is a common factor that both of those will go into? Both of them will go into 6. So we'll make this negative and this one positive. How do you turn -3 into -6? You multiply it by 2. How do you turn +2 into +6? You multiply it by 3. So this is Mg3PO4 2. Final answer. Alright, these notes will be posted on EDU. We'll also go over them in depth tomorrow, but what you guys are going to do right now is you're going to take some time to work through about 10 of these problems on your own. Mr. Jones will go ahead and pass those out to you. Let me know if you have any questions via email tonight, or you can ask me tomorrow. We'll go over the homework in depth tomorrow. Thanks, guys. Have a good day.